Now let's get a little more complicated because I want to get you more used to what you might see on your test. The other one was a good one, but it was pretty basic. I've got a cylinder on top of a cube, and first they want me to find the volume and the surface area. Well, I'm going to go ahead and do the surface area. That's the hard part. Once I get that done, the volume should be okay. To make it easy to start, I labeled all of the surfaces that I'm dealing with. This top part is A1. Around that cylinder is A2. This weird part right here is A3. This side is A4, which by the way goes with that side over there. This front side is A5, which goes with the side and back that you really can't see. And underneath, I call that area 6. So the total area, when I add these all up, you notice A4 had a matching side and A5 had a matching side. So I'm going to say the area is A1 plus A2 plus A3 plus 2 A4s plus 2 A5s plus 1 A6. So let's go ahead and find the different areas. Area 1 is a circle, pi r squared, so it's 16 pi, because you see that 4 right there. I'm going to leave things in pi when I can, because it's just faster. A2, I'm using the formula for a cylinder, lateral surface area from the math chart, which is 2 pi r h. Well, r is 4 and h is 8, so I get 64 pi. A4 and A5 should be super easy because these are rectangles. So I have 8 times 12, 14 times 12, and there's A6, which is this bottom rectangle right here, the 14 by 8, and that's 112. Now I'm going to go back to, so the only thing I'm missing, you notice I skipped one. I skipped A3. Well, A3 is just the same as this bottom surface area. See, if I did that square minus the circle. So I did 112 minus 16 pi. Now if I go ahead and substitute all of this into the formula, I get this. 16 pi plus 64 pi plus 112 minus 16 pi plus 2 of the A4s plus 2 of the A5s plus A6. Now one of the interesting things, I don't know, you'll notice that 16 pi's go away. Because it's kind of like you have the cylinder in here and you pushed it out. See how you have this area on top? It just fills in the hole there. So it's almost like you didn't add the cylinder. It's not critical, you notice that, but it is kind of cool and it could have saved you a little time. Once I use my calculator, I put all the whole numbers together, 752 plus 64 pi. So this is my exact answer. And they asked to the ones place, and when I use my calculator, I get 953 feet squared. That's a big shape. Now, so I found the total area, and now I'm going to find the volume. So I'm really doing volume of the cylinder plus volume of the prism. Both of them use the same formula. It's area of the base times height. So I have area 1, there it is, times this height, 8, plus area 6, which is on bottom, times this height, which is 12. And I substituted in area 1 and area 6, multiplied my whole numbers together, I get 128 pi plus 1344, so that's my exact answer. And once I use my calculator to get my approximate answer, I find it's 1,746 feet cubed. Notice the cubed on volume and the squared on area. In our last example, we're looking at kind of a greenhouse that Ingrid is making so that she can protect her plants from the cold. So she's got these frames and she's putting plastic over it. The question is, how much plastic will she need for each frame? And I wonder, which one do you think will use more plastic and which will use less? Well, I went ahead and labeled my areas of my problem. Area 1, area 2, and I've got 2 area 1s. I've got this side and I've got that side. I do not need plastic on the bottom of the prism, okay? I've got area 2 here and also in back there. So first of all, let's find area 1. That's a nice little square, 10 by 10. So that one's easy. 10 times 10 is 100 feet squared. Now I'm going to find area 2. Well, that's a triangle, and I don't have my height yet. I can see my base is 10, but I'm trying to find my height, which is vertical, and it cuts it in half, so I know this is 5. There's my 30-degree angle. And again, using that same triangle from your math chart, The short leg is the 5. The hypotenuse is a 10. So to find the long leg, you take the short leg times square root of 3. Now, if you didn't know that off the top of your head, if you set up a proportion, it would still work out fine. So now I finally have my height and I have my base, so I can find A2. It's 1/2 base times height, 1/2 times 10 times 5 square root of 3. I'm putting all these regular numbers together. 10 times 5 divided by 2 is 25, and there's my square root of 3. I'm going to go ahead and leave it like that until we get to the final step. So I need to put 2 of these A2s and 2 of these A1s. So A total is 2 A1s plus 2 A2s. I just went ahead and said 200 for 2 A1s. That should be because I have 100 times 2. So I didn't even show 2 times 100. And then 2 A2s, I did show that. There's the 2 times 25 square root of 3, which is 50 square root of 3. Then when you get your calculator, you substitute those numbers in. You should get 286.6 feet squared. Now let's take a look at the one that looks like half a cylinder. A3 is going to be half of the lateral surface area of the cylinder. So it's a half. This is what I added in. This is not on the math chart. And here's the part for the math chart. I added in the half because I only have a half a cylinder. When I go ahead and multiply that out, 1/2 times 2. So 1/2 times 2, I can see that simplifies, right? And so it's just pi times radius times height. So pi times 5 times 10 is 50 pi. That is the area of this section going across it. Now I'm going to try to find A4. A4 is half of a circle. So it's half of pi r squared. R is 5. So that's 25. Half of that, so it's 25 pi divided by 2. Now, when I make this, I just need one of these A3s, but I need 2 A4s. So 1 A3 plus 2 A4s. 50 pi plus 2 times 25 over 2 pi. Guess what? Those two simplify. So you have 50 pi plus 25 pi, or 75 pi. So my total area, when I use my calculator for that, is 235.6 feet squared. So you can actually see that there is quite a difference in area. It's about 50 square feet in difference between going to the triangular area and the semicircle.